Yo guys, what's happening? Let's break our Algebra 1 week in easily. Meaning, let's do an easy lesson today. It's really not bad at all, and I think you guys will like this. You've been doing what I've been able to tell so far from the work that you've turned in pretty well on our chapter on radicals, which, by the way, you may or may not know this yet, but it turns out it's going to be our last new chapter in math this year. Yay! That's cool stuff, isn't it? So today in radicals, we're getting closer to the end. After today, I want to say we have 3 new lessons, and then we're going to review, take a couple of class periods instead of just one for your test. I know it seemed to be a little too much last time for almost everybody to have the test, the entirety of it in one day, so I want to give you 2 days and provide a little bit of leniency and give you some breathing room, okay? But really take your time and do well on it. But we don't have a whole lot of new stuff left, and I'm excited to tell you once we get done through the end of next week testing what we'll be doing for the final 2 weeks of the year. And it just might involve a final itself. We'll see how things go. So today we're going to be discussing the Pythagorean, it's fun to say, try it, Pythagorean theorem. That's kind of fun to say as well. The Pythagorean theorem. Now this is nothing new for you guys, I don't think. I'm pretty confident it's not. Depending on where you stand in the viewership of my teaching videos this day, you may have already heard in Bible class about Pythagoras, or if not, you will hear about Pythagoras. Pythagoras was a Greek philosopher and mathematician, and he and a group of his cohorts they studied at length the Egyptians' use of triangles. And Pythagoras, he lived in the 500s BC, that is about half a millennium before Christ. So the guy's ancient, his work is very old, but it was really ahead of his time. And he was really impressed, and his mathematician and philosopher buddies were about the advancements of the Egyptians and certain things that they knew, and at the top of the things that they knew, and if you've ever looked into Egyptian culture before, it would just blow you away. Just for instance, the pyramids, okay? And by the way, we're dealing with triangles today. But just their pyramid work, but really their mathematical calculations where they would have the sun come into their quote-unquote holy temples at the perfect time of year and illuminate inner chambers. It's crazy stuff. It's really neat. So they were really advanced, they were impressive, and Pythagoras, he noticed this, and so he and his buddies really studied the Egyptians' use of triangles. And in so doing, here is what they discovered. They found, and again this group led by Pythagoras, they found that a right triangle, okay, which has a, and I'm not going to write this in spaces up here like I usually do because we're going to need those for our formulas as our lesson progresses. But what they found is a right triangle, which is nothing more than a triangle with a right angle in it. A right angle is 90 degrees, straight up and down, and with another line intersecting that is straight across. Okay? And so at an end point, and that's what these corners are, end points. So at an end point, there is a perfect 90-degree angle, a right angle. And a right angle can be used to form a right triangle. And so you have 2 bases, all right? And it doesn't matter what we're going to name these, which we'll discuss in our use of variables in just a moment. It doesn't matter exactly what variable or what letter you put on them. You know how that is. I mean, that's just pretty subjective, really. So these are going to be your 2 legs, all right, your 2 legs of your triangle. And then the line that connects the 90 degrees is called the hypotenuse, all right, the hypotenuse. It is hypo, okay, you're going to have the hypo, and then you're going to have T-E-N, 10, hypo, 10, and then use. U-S-E, hypo, H-Y-P-O, 10, T-E-N, use, S-E. That's an easy way to remember to pronounce it. I like to abbreviate personally. H-Y-P-O, period. That's a lot simpler. Hypo. So anyway, you have two legs and you have a hypotenuse. Okay, now here's what Pythagoras noticed. He recognized, and I'm going to write this and then I'm going to erase it, as I sometimes tell you on my small board. This doesn't apply to number 4, but I'm just going to write it up here. He noticed that the two legs, let's say this one's going to be B and that one's going to be A. So he noticed that the legs A squared, or times itself, plus the other leg B times itself, or squared, is equivalent in length to the hypotenuse, which was called C, and also needs to be squared. So A squared, one leg, and it could be either one, doesn't make any difference. We'll say it's this one as an example. A squared plus B squared equals the same length as this one right over here when it is also squared. Not unsquared, but when each one is squared. And so I'm sure you've seen this and used it in math before. A squared plus B squared equals C squared is the Pythagorean theorem. And a theorem is something that is proved, a statement that has been proved always to be true. And it was named after this Greek philosopher and mathematician, Pythagoras, because of his observation of Egyptians' work in triangles. That if you take this leg squared plus that leg squared, it's always going to equal, no matter what the length of one or the other is, it's always going to equal the length of the hypotenuse, or the connector of that right angle, squared. Okay, so that's just a little bit of background. We don't normally do that with our math lessons, but I found that pretty interesting, and so I thought we'd talk just a little bit about it. Now, what we're going to do is we're going to use not this and not this right now. I'll tell you when we're going to get to that, not at this moment. But what we're going to do is use the Pythagorean theorem on this one, and we're also going to use it on 3. Okay? What is the Pythagorean theorem? It is the formula with which Pythagoras came up that tells us A squared plus B squared in a right triangle, okay, not every triangle, but a right triangle, one that has a 90-degree angle, is always going to be equal to the hypotenuse, or the C term, squared. So, here is what we are given for problem number 1. We have this triangle, okay, here's our right angle, and then we have the hypotenuse connecting in what's called A and B, those endpoints, and we need to find the length of side B in this right triangle. We're given these two, but we can use that information to find the one unknown variable. So let's do just that. What are we going to call A? Well, remember, A and B are going to be the two legs of that perfect 90-degree angle always in a right triangle. And it doesn't matter which one you name what, as long as one's A and one's B, and here's why. Look, you're going to add the two terms together. And so if B is here and you add it to A, or A is here and you add it to B, and understood both of those squared, it's still going to come out the same thing no matter what, because it's just simple addition. So it's not a big deal, but because the problem has already labeled for us this leg, B, let's just keep it at that. And let's say this one, CB, okay, is going to be 12. So for A squared, we're going to plug in the bottom leg, which is 12. We need to square that, okay? We don't know what B is, so we're just going to rewrite plus B squared. Now, let me ask you this. Do we know what C, which remember is always the hypotenuse, which is the connector of the right angle? Do we know what C is? Yes, it's the hypotenuse. It's the diagonal, might be the easy way of remembering it. It's not the straight up and down or the straight horizontal line. It's the diagonal line, the slanted line. And so we do know what the hypotenuse, or C, is. That's 15. And so guys, all we do is just plug in 15 for C. But don't forget, every single term is squared. Okay, so from that point, let's do this in our head. What is 12, not times 2, but 12 squared, which is 12 times itself? What's 12 times 12, guys? 12 times 12 is 144 is correct. 144, okay? Plus b, not just b, but b squared, okay? B squared equals 15. All right, so what is 15 times 2? 15 times 2, I want to show you, oh, look how young the night still is, Mike. It's only 9:10. All kinds of time for things to do tonight. Okay, so we have 15 squared, which is 15 times 15, same difference. I could do 15 with the little 2 above, or I could just do 15 times 15, same thing. That's 225, okay? 225. That was 15 squared. All right, guys, what do I do in my equation now? 144 plus b squared equals 225. This is a two-step equation, so everything I know is wrong. And therefore, I'm going to start with this positive 144 that's sitting out there so I can get b squared all by itself. And what I'm going to do is subtract that positive 144 from both sides, which gets rid of it on my left side. Okay. And since I'm running out of space, I'm going to write it right up here, okay? B squared equals, what is 225 minus 144? 5 minus 4, of course, is 1. Okay, 5 minus 4 is 1. What is, obviously I'm going to have to borrow from to make that a 12 right there, okay? What's 12 minus 4? 12 minus 4 is 8. And so I have b squared equals 81. I'm trying to solve, though, for b, not for b squared. What is the opposite, or what is the inverse of b squared, or just squared in general? In other words, how do I get rid of a squared? What's the opposite operation mathematically I have to apply? That, of course, is a square root. And now you see why the Pythagorean theorem fits into the concept of radicals? Because you have squared numbers, and to solve for a variable, you have to take the square root. And the very definition of a radical is applying the square root to something. Okay, so b squared equals 81. Take the square roots of both sides. And what I have is, what's the square root of 81? Or what times itself gets you to 81? The beautiful number of a single digit called 9. So my answer is 9. B equals 9. 9 squared plus 12 squared equals 15 squared. And it's not 9 plus 12 equals 15. That's different, but when each is squared, then that is a true statement. Now, number 2, what we're going to do here, number 2, is we're going to find the length of the hypotenuse in the right triangle, ABC. And that's just the name of the triangle, ABC, because those are my 3 endpoints that have been named such. How am I going to do that? Using the Pythagorean theorem. What is that? The formula is a squared plus b squared equals c squared. And this time, how about I don't rewrite it, because look how tiny my space is. And that takes up a whole precious line. So we'll just point up here. A squared plus b squared equals c squared also applies to this one. All right, so what is A? What is A? Remember, it doesn't make any difference if you name that one A or that one A. So let's just do one. Let's just say, we'll just start bottom here, which is so happens to be close to the letter A. That's coincidence, but we could use this leg or this leg for A or B. Remember, whatever forms the 90-degree angle, one of them is A and the other one's B, doesn't make any difference which is which. So let's do this one, 20, and a squared, so it's going to be 20 squared. This time I'm not going to do parentheses because I'm just adding. Really I don't have to. 20 squared plus, do I have a B? Yes, I do. Whatever lines form the 90-degree angle, that's 10. So 20 squared plus 10 squared equals the hypotenuse, the diagonal line, which is c, and that also needs to be squared. So 20 squared plus 10 squared equals c squared. Guys, we can do these two in our heads. I'm going to use our calculator for this one. Here's why. What is 20 squared? What is 20 times itself? Well, that's really easy because what's 20 times 2? 20 times 2 is 40. And all we need to do is just add a 0 to it. Because we're doing 20 times 20, just do 20 times 2 and then tack on that 0 at the end that we didn't use. And so 20 squared, or 20 times itself, is 400. What is 10 squared? 10 times itself. Well, that's a really easy one. We know 10 times 10 because that's in the multiplication table. That is 100 equals c squared. What is 400? Two-step equation, everything I know is wrong. Do addition first. And these are on the same side, so we're not moving anything left or right here. We're just combining like terms. What's 400 plus 100? That is 500 equals c squared. Dirty finger erase. Didn't put my square in a good spot. Okay. 500 equals c squared. Now guys, it's a one-step equation. So how do I solve? The one thing left to do to isolate c all by itself is what? What's the inverse, the opposite operation of a square? It is a square root. And so I take the square root of both sides, which is going to leave me with c. And because I've run out of space, I'm going to finish writing up here, but then I'm going to erase once I get there, but that'll give you a couple of minutes still to write that down. So I have the square root of c squared, which is just going to be c. c equals, what's the square root of 500? There are two ways of doing this, and here's the way I want you guys to do it. Since we've been dealing with simplifying radicals, let's not just punch that into our calculator and get a decimal. Let's leave our numbers whole, one of which, okay, and actually technically as a combined term, it's going to be a radical because we'll have a number under a square root. Let's look at this number and let's ask ourselves, is there any multiple or factor of 500 of which we know that is a perfect square? Let's break it down. Remember how we were doing those? Is there any factor of 500 that of itself is a perfect square? Well, there's one that really stands out. It's a huge number. You know what number that is? 100. We know that 100 is a perfect square because we know what times itself gets us to 100. So let's use 100, and 100 times what gets us to 500? That's the number 5. And so here's the way we're going to write c equals square root 100 times 5 under the same happy square root umbrella. And the reason we do that is because we know we can easily just pull that 100 right out to the front. What's the square root of 100, or what times itself gets you to 100? That is the number 10. And therefore, we can pull the square root. Remember how we've been doing? I know we had a long weekend. All last week we were doing this, so this isn't new information to us. We can take the square root of 100 and pull that answer out to the front, leave it multiplied to what's underneath still. That square root is the radicand. So the 100's been pulled out. The square root of 100 simply is 10. But we still have square root 5, and because that's a prime number, we cannot break that down any further. But again, this correlates over here with number 2. I just run out of space, and so I don't have to splice videos together or erase important stuff you might still need to copy down. We'll just do it that easy way. So, what is the hypotenuse in number 2? In terms of a radical, and not putting it into decimal form, it's 10 times the square root of 5, and that is our simplified answer. So let's give number 3 a shot now. Here we're not given a drawing, we're just given words and numbers. We are being asked in number 3 to use the Pythagorean theorem to find the distance between endpoint 1, which is negative 3 as an x value, 1 as a y value. We're incorporating several things here that we've learned, aren't we? And endpoint 2, which is 5 as an x value, and 4 as a y value. And guys, if you want, just like we did when we were graphing, we can label these x1, y1, x2, not another x, we need a y there, don't we? y2. Go ahead and label those that way if you want. That is one way of doing it. And we could actually graph this and find the answer through graphing. I'll just be truthful with you, I don't want to do that. Do you? That's a lot of work to me. I don't know about you, actually I do. But I as well like to do things the easy and the shorter way, so let's just do it that. We could graph it, and you guys know how to plot points, and from there that gives you a hypotenuse, which you could then just draw a right angle, and you could complete it from those 2 points that you're given. Let's not do it that way though. Let's do it a simpler way, and let me show you how. What is the difference between your x values? What's the difference between your x values? In other words, how many spaces are there between negative 3 and 5? Between negative 3 and 5. Well, if I go 1, 2, 3 spots, I'm at 0. And then I need to go how many more spots to get to my second point? 5. So what's 3 spots or units plus 5, the difference between the first x value and the second x value? Guys, the difference between those is 8. 8 spots. And so there are 8 spots that are different in my x value. And the way I do that, the difference, negative 3 minus 5 is negative 8, but you're not going to have a negative length, okay, in a shape. So it would be the absolute value in 8. Or you could do it this way, 5 minus negative 3, the difference between the two, which would make it a plus 3. What's 5 plus 3? 8. And so that's the way we're doing it. How about this one right here? You could do 1 for your y value, okay? You could do, for your y value, 1 minus 4, which is negative 3. We're going to do the absolute value of that, though, because you're not going to have a negative length in a shape. So it would be 3. Or if you prefer to make it easier, just do 4 minus 1. And 4 minus 1 is 3. But you see how I did that? I just subtracted 1 from the other. And you can do that either way, as long as you understand it's the absolute value that is being involved there. So what we're going to do now, is try to use the Pythagorean theorem to figure out what is the length, okay? What is the length or the distance between these two endpoints that we're given? Well, we found a difference just straight off the bat, but now we have to plug these two numbers into the Pythagorean theorem. A squared plus b squared, these two added together is going to end up giving us our hypotenuse and its length, c squared. So let's do 8, and remember, it doesn't matter in what order you do it. Let's do, for our x value, let's call that our a, all right? So we're going to plug in 8 for a, and we're going to square that, because a squared plus b squared, which is what? We're going to use our y value for that. 3, so 3 squared equals c squared, our hypotenuse that we're still seeking it out. 8 squared plus 3 squared equals c squared. What is 8 squared? 8 times 8 is 64. Plus, what is 3 squared? 3 times 3 is 9 equals c squared. What is 64 plus 9? 64 plus 9 is 73 equals c squared. Guys, how do I solve from this point? I have to shed that square that is attached to that c. I do that by applying the inverse operation, which is making a radical of this number. But to do that, I have to take the square root of c squared, which is going to drop the squared and just give me c. All right, I'm going to drop the squared and it's just going to give me c. And what is going to be the solution to that? What do you think the square root of 73 is broken down? You're not going to be able to break that down any more than what it is. And so it's just the square root of 73. That's it. That's going to be your answer. Not too bad stuff, huh? Now what I'm going to do is erase the further answer, the complete simplification number 2 that's under number 4. And what we're going to do for number 4, listen to me on this one. We're going to use the distance formula to find the distance between 2, 1, okay, the first one's your x value, the second's your y value, and 5, 1, first one's your x value, the second one is your y value. I'm going to use the distance formula. What in the world is that? Okay, that's where we need to talk about these two. And for right now, this one, d equals, can you see this okay up here? D equals the square root, and this is over everything I'm about to say. The square root covers every bit of it. D equals the square root of, open parentheses, x2 minus x1, close parentheses, and that becomes squared, plus, open parentheses, y2 minus the first y value, close parentheses, and that also is going to be squared. So d equals the square root of x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared also. So let's just apply this distance formula right over here. And I'm going to start writing over on this side. But the first thing, guys, I'm going to do, since it's been a while since I've worked with these, and you too, I'm going to label x1, y1, x2, y2 as my points up there, so I don't get confused. And what I'm going to do for this first one, I probably won't continue to do it for every one because of the space that it takes. I'm going to write my distance formula. Sorry, my nose is all itchy. Spend too much time outside today. D equals the square root of, okay, it's going to be x2 minus x1, close parentheses, squared, plus, continue that big long square root sign, plus, open parentheses, y2 minus y1, close parentheses, squared. Are we good so far? All I've done is just write my distance formula, and I've been told in the problem, use the distance formula to solve this equation. So that's exactly what I'm going to do. I'm going to write d equals square root big long again, and I'm going to plug in all my values that I'm given right here to find d, or the distance between those. So what I'm going to do is I'm going to plug in x2 for my x2, which is 5. Open parentheses, remember. 5 minus my x1, which is 2, so 5 minus 2, close parentheses, squared. Plus, open parentheses, what's my second y value? I've labeled that as 1 minus, what's my first y value? 1. That'll be an easy one to simplify, huh? Close parentheses, squared. Now what I need to do is simplify, keep my big long square root symbol, simplify what's in each parentheses. 5 minus 2 is what? 3, keep that in parentheses, and squared, plus what is 1 minus 1? Obviously goose egg, so I'll put 0 in parentheses and square that. But we understand, don't we guys, that that's nothing. 0 times anything is 0. 0 times itself is still 0, so we'll just get rid of that. And all we have is the square root of 3 squared. So distance is going to equal then the square root of, what's 3 times 3? That's 9. And what is the square root of 9? Or what times itself gets you to 9? The numeral 3. And so my answer, even though I wasn't given feet, centimeters, inches, that type of thing. I'm going to go ahead and write though, just because I like to label and I like to do a little too much as opposed to not quite enough on something. I'm going to put units, whatever those units are. So the distance between these two endpoints is 3 units. And that's measured and found via the hypotenuse. Okay, number 5. Let's do the same thing that we just did here. Number 5. On that one, we are going to do the distance, as in finding it, between -2 and -9, as well as 6 and -5. Guys, first thing I'm going to do is I'm going to label x1, y1, x2, y2. You may think that's silly, but it would blow you away how many answers are missed because that simple first step is not taken and confusion results because of it. I'm not going to rewrite my distance formula because I have it here and I wrote it once the first time and I just don't have space. And plus it saves us time, which is a beautiful thing too. But what I'm going to do is put D equals big long square root of x2, which is what? I've labeled 6. See, that makes it really easy when you label, doesn't it? It takes all the thinking out of it and it just becomes systematic, which is what math was designed to be. So the square root of x2, open parentheses, x2, which is 6, minus x1. Now think about it, if I have minus -2, what's going to happen to that sign in front of the 2? It's going to become a positive, and so I'm going to have 6 plus 2 instead of -2. That's squared plus, you see what I've done so far? Plus y2, which I labeled as -5, minus y1, which is -9. And if I have minus -9, what happens to that sign in front of the 9? It becomes a positive, and so I'll have plus 9 and then squared. So let's simplify what we have thus far. Big long square root still. What is 6 plus 2? 6 ordered operations, parentheses come first. 6 plus 2 is 8. Keep that in parentheses, squared. Plus, what is -5 plus 9? And guys, I always feel like these are easier if you just reverse it and say positive 9 minus 5. 9 minus 5 is a whole lot easier than -5 plus 9. So 9 minus 5 is just 4 in parentheses, and that will be squared. So let's write up here now, D equals, we still have our square root, we need to simplify these guys. What is 8 times itself? Not 8 times 2, but 8 times 8 is 64. And what is 4 times itself? Because it's squared. 4 times 4 is 16. And now we can look at this and we can say, what is 64 plus 16? Well, that's easy because 4 and 6 is a 10. That's a 0. Carry your 1. 6 plus 1 is 7. But then add your 1 that you carried is 8. So D equals the square root of 80. D equals the square root of 80. Let's not punch that into our calculator, but let's do what we've been doing and break that down further and simplify that as a radical, but pull a number out in front by which it'll be multiplied. What is a perfect square that you see in 80? What is a perfect square that you see in 80? Obviously, the number 4 would work, wouldn't it? And you could divide 4 into 80, which would be 20. But I'll help you out with a little shortcut here. You have 20 left over, but there's another perfect square as a multiple in that, which is 4. And since 4 is found as a multiple twice, what is 4 times 4? That's 16. Okay, this is just some head math, but look at, I want to show you something on my calculator. Now it's focused in. 80 divided by another perfect square, which is 16. And if 4 will come out of it twice, that means 16, or 4 times 4 has to come out of it. Now you can go the long way and just do the 4 and then do 4 again. But why do that when you can see a shortcut that's available? So 16 and 5 are two factors of 80, 16 being a prime one. And so what I'm going to do is write d equals square root 16 times 5. And I do that because I know I can pull out the square root of 16 to the outside. What's the square root of 16? 4, because 4 times 4 gets you to 16. And so my solution to my dilemma is going to be 4, but what do I still have underneath the square root symbol with which I can do nothing? That is the number 5. And so my answer, not in decimal form, but in radical form, will be 4 square root of 5. And if I had room, I would write units, even though I'm not told it's meters or it's, whatever you want to call it, yards. But it's units, and so that's the way I would answer that. Number 6, one more, and then we'll call her quits. Number 6 is, let's find the midpoint of the segment with endpoints of -3, 1, and 5, 4. First thing I'm going to do, I'm going to do this below just because I ran out of room on top. I'm going to label these x1, y1, x2, y2. But I'm not going to be using the distance formula. I have a formula for midpoint, which is, the formula for midpoint is x squared plus x1 divided by 2, comma, which will give me my x value, comma, so it's written as an ordered pair, y2 plus y1 divided by 2. And that sounds kind of complicated, but think about it, guys. All we're doing is adding together the two x values and finding their average by dividing by 2. We're just finding the average of the y's by adding the two y numbers together and dividing by 2. That's the way you find an average of two numbers. So really you see it's not significant in concept at all, and that looks, it doesn't look that bad, but it looks even more confusing than what it so simply is. So my formula for midpoint is x2, I'm not going to rewrite that, okay? But I'll put m equals, what is my x2 value? 5. Okay, plus what's my x1 value? -3, so instead of writing 5 plus -3, the negative is going to override. And I'm just going to write 5 minus 3 divided by 2, comma, which tells me it's going to be written as an ordered pair, x value here, y value there once I simplify. My formula says my second y value, which is 4, plus my first y value, which is 1, divided by 2 as well, close ordered pair. Now let's just simplify. M equals, what's 5 minus 3? That's 2. Retain your over 2. Okay, in other words, just keep your division sign and your 2. Comma, for your ordered pair, let's go ahead and put our parentheses around it too. What's 4 plus 1? Obviously 5. Over dos. Close the parentheses of your ordered pair. Now simplify, and guys, we're done already. And I'm just going to keep it on the bottom right here to make it easy. What's what my midpoint? What is 2 divided by 2? Uno. Comma. What is 5 divided by 2? 2 will go into 5 evenly 2 times, with a leftover of 1 over the denominator 2, 1/2. What is 1/2 as a decimal? 0.5, close parentheses. So my midpoint, given the two endpoints in this triangle, my midpoint is, as an x value, 1, comma, as a y value, 2.5. And so that incorporates things that we learned much earlier in our math classes this year. So that is our math lesson for the day, guys, the Pythagorean theorem. Really noticed and named after the Greek philosopher and mathematician Pythagoras. Pretty cool stuff, neat background too.